Alright, so now that we've had a chance to introduce arrays, we're going to take a look at how to actually start processing the elements in our arrays. So essentially what that means is we're going to look at how to perform some kind of math calculations, or maybe be able to use them for comparisons or logical operations. So the individual elements of an array can be processed in various ways. This includes many different operations such as multiplication or addition. So we've got an example right here where we're going to multiply the value that is at position 3 of some array that is called hours. So we're getting that hours at position 3. We're going to multiply that by some other variable that we call our pay rate. So essentially what we're doing is we're just taking the number of hours that somebody worked, we're multiplying that by their hourly pay, whatever their pay rate happens to be, so that we can go ahead and figure out what their gross pay happens to be, or just however much money they happen to make over some span of time. Possibly for a weekly or bi-weekly salary. Another example that we have right here, we can increment the value at some position, say maybe position 4 of a variable, an array that we call score. So we've got score at position 4, and we see that plus plus, so we have that increment operator. So we're essentially just taking whatever value is at that position of the array and just incrementing that by 1. One thing to keep in mind is that whenever we do this, we want to make sure that our operations are outside of that pair of brackets. So if you were intending to perform some kind of operation on the position itself, you would then have to put the operations inside the brackets. So we see an example right here where we're decrementing the position of count and then retrieving the value, that value from our amount array. So whatever count happens to be, say maybe this is currently, it holds the value 2, for example. So whenever we complete this operation here, we're going to decrement it. We're going to subtract 1 from count, so it goes down to position 1, and then we're going to go ahead and get the value that is at that position of amount. So remember the order of operations with a post increment or post decrement. So in this case, we're doing it with specifically in this case, we're doing it with a pre-decrement, so we're making sure that we decrement first and then continue to do all of the other operations. If we were to flip this, do a post-decrement, then what ends up happening is we're going to get the value that is at whatever position count currently specifies, and then after doing that, we would decrement count. So keep in mind the distinction between pre and post increment and decrement and how that affects these operations. So in addition to our math operations, our array elements can also be used as part of Boolean expressions. So the example we have right here, we're essentially saying that while some condition is true, so in this case we're saying while the number, or in this case the number at some position in our value array, that position being specified by count, while that is not equal to 0, then we can go ahead and execute some of the statements that we have right here. So what I want to go ahead and do is put together a fairly simple program that's going to just take an array. So we'll go ahead and just have our already initialized array. We'll do a little bit of processing with that and then print out the contents of the array after we do that processing. So we'll go ahead and minimize this. We'll come over here. And we'll go ahead and create a new project. So we're going to go ahead and create a new job application. Click Next. For this one, I'm going to call this one just Array Processing. Go ahead and click Finish. We'll go ahead and remove the extra comments and make some adjustments to the style of this. And right here inside of the main method, to start off with, let's start by just creating an int array. So we're going to do int and then a pair of brackets. We'll call this one something like, let's say grades. And we're going to initially set this up to just have some predefined initial values for it. So let's start off with something like, say, 3 different grades. So we can start off with something like, say, a 66, 73, and maybe like an 81. Okay. So then what I want to go ahead and do, since these grades aren't looking all that great, I want to go ahead and give them a slight curve. So what I'm going to go ahead and do is just create a for loop where I'm going to step through each one of the items in this array that I have right here, and I'm going to increment, or in this case actually add an amount to each one of them. So we're going to do something like, let's say about 10 points, bump it up enough so that at the very least the highest grade is an A. So let's say something like for int index equal to 0. So again, we're going to make sure that when we do our for loop, that our index starts at position 0. So that's going to specify position 0 of the array, or index 0 of the array. The next thing I'm going to need is going to be my condition. So I'm going to say that as long as our index is less than whatever this size happens to be, so in this case it's going to be 3. So we'll go ahead and do that right there. And then finally, we want to make sure that we're incrementing each index on each iteration of this for loop. So we're just going to say index plus plus. And then for this one, I just need a single line of code for this. All I need to do right here is just take whatever value I have at a particular position in this array. I'll add 10 to that, and then I'll store that back into that same position. So if I were to write this out completely, what I would have is something like my grades at this position index is going to be equal to whatever value that position currently holds. So we'll do that again on the right-hand side of our assignment operator, and we're going to say plus 10. So you'd have something kind of like this, but based on what we're looking at right here, this seems like a pretty good opportunity to just use a combined assignment operator instead. So rather than doing it this way, I'll just say that my grades at position index, and then right here we'll use a combined assignment operator and say plus equals 10. So we're going to take the value 66, we'll get that from our array, we're going to add 10 to it, we'll make it 76, and then we're going to assign that or store that back into that same position. So the 66 will be updated to 76, the 73 will do the same thing, we'll take that, add 10 to it, store it back into its same position, so 73 becomes 83, and this 81, do the same thing, that becomes 91. So the end result, if we go ahead and print this all out to the console, we're going to say for int index equal to 0, index less than 3, index plus plus. Then what we want to go ahead and do is just print this back out. So let's go ahead and take a look at each one of the individual grades. So we're going to do system.out.println, and we'll go ahead and say grades at position index. Okay. So this will go ahead and let us see what the array looks like after we've done our processing, in this case applying that curve of 10 points to each of the grades. So if we go ahead and run this, we can go ahead and see our 76, 83, and 91 for positions 0, 1, and 2 of this array. So at this point, with what we've got, this looks pretty good, but in order to do this, I had to hard code these values, these 3 different numbers. Ideally, if you want this to be more like a full-fledged application, you would typically make it more flexible and more general purpose by letting the user specify their own values. So let's go ahead and kind of modify this a little bit to let the user do that. So we're going to go ahead and bring in the scanner class. So we're going to do import java.util.scanner. We'll go ahead and save that. Right here, we'll go ahead and bring in, or kind of use our scanner class. So we're going to make that object keyboard. So we go to a new scanner that can read from the keyboard input. So it's going to be with system.in. And then right here, instead of hard coding these values, I'm going to let the user enter their own values. So we're going to say something like new int array of size 3. We'll go ahead and save that. And then right here, what I'll go ahead and do is we're going to work under the assumption that the user is using this particular program because they have a list of grades that they want to apply a curve to. So they're just entering the grades. It'll immediately calculate the curve for them. And then when we're all done, we'll just go ahead and print out the curved grades. So we're going to need something like 3 lines of code for this. The first 2 are basically just getting the user's input and storing that into the proper location or the proper position in the array. And then the last line is what we have already, which is just incrementing or increasing those values by 10. So right here, we're going to do system.out.print. We're just going to say, please enter a grade. And then on the next one, we're going to go ahead and take our grades at position index, and that's going to be equal to, so in this case, we're doing our initial assignment of whatever the user's input happens to be. So we're going to do keyboard.nextInt. Okay, so we'll ask the user to enter a grade. We'll take it based on this call to the nextInt method. We'll go ahead and store that into the current position that we're at in the array based on our current iteration in this for loop. And then once we have that, we'll also go ahead and increase its value by 10 and store that result back into that same position. So now if I go ahead and do this, I could start off by just entering the same 3 values. So we go ahead and run this. We can go ahead and say something like 66, 73, and 81. And so then the end result is going to be 76, 83, and 91. So I'm just going to increase each one of those by 10. So this gives us the same output that we had before. If I wanted to, I could also specify some other set of grades. So we could do something like 54, maybe 67, and something like 72. And then it'll go ahead and increase each one of those by 10. So we get 64, 77, and 82. So at this point, this is looking a little bit better, but there's also one other problem with this now, which is that I've at least made the correction so that now the user can provide their own values to the array, but I should also let the user pick how many values that are going to be in the array. So what exactly would the size be? So in order to do that, I need to let them specify this number right here. So what I should go ahead and do is, after creating this keyboard object, I'm going to go ahead and add another print statement right here, making a request to the user to go ahead and specify how many values should be in the array, or in this case, how many grades. So I'm going to say system.out.print. How many grades are there? And then we'll just have a little colon and a space. I'll go ahead and enter the number right here. And then what we can go ahead and do is, instead of doing this 3 right here, what I'll go ahead and do is just replace this with the keyboard.nextInt. So I'm going to put that right in there. And so now this line right here, because we're making this call to nextInt, that's telling the program to go ahead and wait until the user has entered something. And then once they have, we can go ahead and execute that entire line of code on line 13 right here. So then we can go ahead and just take whatever size they gave us. That's what we're going to go ahead and use right here. But now, once they've done that, we need to come over right here, and we need to go ahead and correct this 3. So we see that for each of these 2 for loops, we can't really use this 3 anymore, because now if the user gives us any value other than 3, then this isn't really going to work. If it's less than 3, we're going to run into that index out of bounds exception, and if it's more than 3, then we're going to have a bunch of extra grades that we can't actually input because we stopped too soon. So what we need to do is take a look at another portion of our arrays that will allow us to kind of add on to the functionality of it. So arrays actually have a useful field for tracking the length. Using an array's length field, users can specify the size of an array at runtime. So in this particular case, the example that I'm using here approaches this in a slightly different way, where we are starting off with our keyboard object. So we've got scanner keyboard equals new scanner, reading from system.in, so reading from keyboard input. We then go ahead and declare the variable for our int array. So we've got int array numbers. In this particular example, I initially set that to null, so I'm doing it a little bit differently, where I just do the declaration and the construction all in one line. This one kind of breaks it up into 2 separate lines. So we can have our system.out.print line, enter the size of the array. We can then do numbers is going to be equal to that new int array. Again, you can see right here that syntax where I have keyboard.nextInt placed inside of the array's constructor, so it's inside the brackets. The next thing I go ahead and do is actually get the length field of my numbers array. So that length field is going to match up with whatever the user just gave me. So in this case, I'm just going to assign that to another variable just to kind of make the code a little bit shorter. We can take a look at both ways to do this. But essentially, we're going to be using numbers.length to give us whatever the size of the array happens to be. So go ahead and minimize this. So coming over here, instead of using this 3, we're going to go ahead and replace this with our numbers, or in this case, grades dot length. So we just want to go ahead and get that length field from our grades array. And we want to do this for both of these for loops. Okay, go ahead and save that. And so then if we go ahead and run this, so now we're going to first say how many grades are there. So let's say maybe there's still just 3 grades. Then we go ahead and enter our grades. So this request to enter a grade, this will continue to display a number of times equal to whatever you just specified right here. So in this case, it's going to do this 3 times. So we have 3 grades to enter. So maybe we can go ahead and use some pretty similar values. So we have something like 56, 68, and 73. And then at the end, it'll go ahead and do 66, 78, and 83. So again, we can see the same general behavior. We're just making it more flexible for the user now. So then, of course, if we ran this, if we did something like 5, we could actually go ahead and specify 5 grades for this now. So maybe in that case, we're starting from the lowest grade and going up. So we have something like 49, 57, maybe 62. So at this point, we've already entered 3, but it'll keep going. So we'll do something like 75, and then maybe 88. So now when we do it, it'll go ahead and do this with 5 values. So it'll let us enter 5 values, and then it'll also go ahead and print out all 5 of those values with the 10 added to them. So now we get 59, 67, 72, 85, and 98 as the output for this. So at this point now, we've got the complete program with the request to the user about how many values we're going to enter, how many grades are there going to be, and then also what are those grades going to be. All right, so one of the last things I want to talk about in this particular instance with processing array elements. So since for loops are frequently used with arrays, as you can see, we pretty consistently have to use for loops for things like adding values to arrays, performing some kind of operation on each one of the different elements of an array. If we want to print out all the contents of an array, that also requires a for loop. So ideally, we want a more concise way to do this to kind of shorten up the amount of code that we have to write. This more concise form for our for loop, this is going to be known as the enhanced for loop or the for each loop. Variable is used as a placeholder for the current element of the array being accessed. So the naming convention for this, the reason we call it the for each loop, it kind of comes from how the line is read. Basically what we're saying is for each number in the numbers array, in our case that'll be for each grade in the grades array, we're going to do something with that number or with that grade. So ideally you should use the for each loop whenever possible, as this eliminates the possibility of off by 1 errors. So if we come back over here, we can go ahead and use the for each loop for our print statements right here. So what we're going to go ahead and do is, instead of doing all of this, we'll go ahead and remove all of that. And now what we're going to go ahead and do is say for, and we're going to say int grade. So we're going to use this variable that we have to declare as our placeholder for each of the individual items inside of our grades array. We then have a colon, and we then have grades. Okay. So then, instead of having to do grades and then some kind of index, kind of like what we did for our more traditional for loop, now we can just use this grade that we have right here, this variable. So go ahead and remove this. And so now what we end up with is for each grade in grades, print that grade to the console. So we can go ahead and see that right here. So we'll go ahead and run this. And so now what I can go ahead and do is maybe something similar to what I had before. We'll do this one with 3 grades. So we'll do something like 66, 74, 83. So then we can go ahead and see that print to the console. The key difference now is just that the loop that we're using right here has been shortened down a fair bit. So one of the other things that's really convenient about this enhanced for loop, in addition to the fact that it's less code than writing out this entire traditional for loop, you'll notice that because of the way that we've constructed this, we don't have to keep track of the index, which also means that we eliminate the possibility of any off by 1 errors. We're guaranteed to start at position 0 and end at the length -1 because of the fact that we're relying on just these this placeholder that we have right here and kind of the internal logic of how this for each loop actually works or how it operates. But there's a little bit of a catch. I mentioned that you should only use the for each loop whenever possible. So there are going to be instances where you can't actually use it. So let's take a look at those as well. So there are going to be a few cases where you cannot use an enhanced for loop. So I'll go through each one of these 5 cases and explain a little bit about why it is that you can't use it here. So in the first case, anytime that you want to change the contents of an array element, you cannot use an enhanced for loop. The variable used in the loop is only a placeholder, so assigning a new value to that variable does not affect the array. So if you were to take, say, this portion that you have right here, assuming that you have this grade right here and you try to assign something to it, assigning something to this variable will not directly affect the array itself. It only affects this placeholder that you're using for it. So if you need to assign something to the array itself, kind of like what we do right here and technically right here, you have to use a traditional for loop instead. If you need to work through the elements in reverse order, not necessarily just reverse order, but any sort of peculiar order other than just going from the beginning to the end, you wouldn't necessarily be able to do this. The enhanced for loop is going to have a preset order to step through the array. So anytime that you need to step through the array in some order other than from beginning to end, you will very likely have to use a traditional for loop instead. If you only need to access some array elements, particularly if you only need to access a subset of items in the array, a more efficient approach is to just use a traditional for loop with the proper positions in the array. So what this is primarily referring to would be if you have a very large array. So in some cases you have enormous amounts of data that are being stored in arrays, maybe something like a few thousand or tens of thousands of items inside of them, but you only really want to look at, say, maybe about 10 or 20 of those items. It doesn't really make sense to use the enhanced for loop, the for each loop, because of the fact that that has to step through every single one of those items, but you only really care about a very small number of those items. So instead, you should use a traditional for loop and then just specify the beginning and end positions that you actually care about. If you need to work with multiple arrays in one loop, this will become more apparent whenever I start talking about comparing and copying arrays. So that particular case I will come back to once we start introducing those two algorithms related to arrays. For the final bullet, whenever you need to reference the subscript of an element, so this one seems pretty apparent just based on the syntax of the for each loop. So the enhanced for loop is going to use variables in place of requiring you to access the subscripts of array elements. But in some cases, this functionality is not desired. So if, taking a look at this, if for whatever reason you need to use this subscript, so this position that we specify right here, if that is actually your requirement for whatever it is that you need to do, then you cannot use an enhanced for loop, since this only provides you with a placeholder that holds the value of it, but doesn't really hold the position of the array. Alright, so this is going to wrap up everything for taking a look at processing our array elements. In the next video, we're going to take a look at how we can go about taking the contents of one array and copying those into another array. So we'll kind of see why it is that what we're accustomed to doing with our primitive data types, where we just assign one variable to another, why it is that we won't necessarily be able to do that with our arrays, and how we can properly copy the contents from one array to another.